Welcome back. So today we will solve all the questions from Matrices which came in different shifts of April 2025 attempt. And in this series we will solve questions chronologically date-wise. So in Matrices we have total 11 questions, out of which 5 are easily doable and 6 are moderate, which we are going to solve. Here is a disclaimer that this difficulty level is based on my perception, which may be different for others. So let's move on to our first question. Here is our first question. Our question says, let A belongs to R, A be a matrix of order 3 cross 3, such that determinant of A is equal to -4 and A plus I is equal to this matrix, where I is the identity matrix of order 3 cross 3 if this determinant is 2m3n, where m comma n belongs to this interval, then m plus n is equal to. So first, to solve this question, we need to find, we will compare determinant of A is equal to -4, then we will get the value of A, then we can easily find the values of m and n from this. So our A is equal to this matrix minus the identity matrix. So it will be 0, A, 1, 2, 0, 1 minus 1, 0, 0, A, 1, 2 minus 1, 1. So here is our matrix A. Determinant of A is equal to minus 2A minus 2A plus 2 is equal to -4. From here our A is equal to 3. Our A is equal to 3, then this determinant will be determinant of 3 plus 1, 4 adjoint of 2A. So this is equal to 4 cube determinant of 2A whole square. This is equal to, we can write 4 cube as 2 raised to power 6. And we can write here 2 will get outside the determinant, 2 cube, and 2 cube square will be 2 raised to power 6 into determinant of A whole square, which is 4 square. So 2 raised to power 4. From here this is equal to 2 raised to power 16 into 3 raised to power 0. This is equal to 2 raised to power m into 3 raised to power n. So from here our m is equal to 16 and n is equal to 0. Now the question asks us m plus n. So m plus n is equal to 16. From here our option D is correct. And here is our solution, and we can see that our answer is correct. Here is our next question now. This time our question says, let A is equal to this matrix, alpha is greater than 0, such that determinant of A is equal to 0 and alpha plus beta is equal to 1. If 1 denotes 2 cross 2 identity matrix, then the matrix 1 plus A raised to power 8 is. So here in this question, First we will use these two equations to find value of alpha and beta. Then we will evaluate the required expression. So here in this question, determinant of alpha 6 minus 5 beta is equal to 0. From here this is equal to alpha beta plus 6 is equal to 0. So our alpha beta is equal to minus 6 and alpha plus beta is equal to 1. From here roots are 3 and minus 2. Our alpha is greater than 0. So alpha is equal to 3 and beta is equal to minus 2. Now we can easily write our A is equal to 3, 6 minus 1 minus 2. 3, 6 minus 1 minus 2. Now I plus A raised to power 8. Using binomial coefficients, we can write it as, or first, let's calculate A square. A square is equal to 3, 6 minus 1 minus 2. 3, 6 minus 1 minus 2. So this is equal to 9 minus 6, 3 and 3 minus 3 plus 2 minus 1. 18 minus 12 and minus 6 plus 4. So from here we can see that our A square is equal to A. So from here we can say A is equal to A square is equal to A cube and so on. Now we will write I plus A whole raised to power 8 is equal to, we will take A common and inside we will get 8C0 will get cancelled, will not be, so 8C1 plus 8C2 plus dot 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 till 8C8 and plus 8C0 into I. It will be only I. So this is equal to 2 raised to power 8 minus 1 into A plus I. This is equal to 2 raised to power 8 64 into 4 256 minus 1 255 A plus I. So from here this is equal to 255 into 3. 255 into 3 will be 255 into 3. It will be 765 plus 1 766 and minus 1, so simply minus 255 and with into 6 we will get 0 3 33 3 3 1 5 3 0 and the last one 255 into 2. So this will be 0, 1, 1, 1, 510 minus 1. So 509 with a minus sign. Because here we have minus 2. Now let's check the options. 766 minus 255, 1530 minus 509. Our option D is correct. And here is our answer. So from here we can see that our answer matches correctly. Here is our next question now. This time our question says, let A be a 3 cross 3 real matrix such that we have this equation where I and 0 are identity and null matrices respectively. If A5 is equal to this, where alpha, beta and gamma are real constants, then alpha plus beta plus gamma is equal to. Now from this above equation, we can say a cube is equal to 2a square plus 4a plus 4a minus 4a. So this is a cube. Now we will multiply both sides by a raised to power 4. Well, this is an important result. We will use it again. A raised to power 4 is equal to 2a cube. So we will again use this. 2a square plus 4a minus 4i plus 4a square minus 4a. So this is equal to 4a plus 4a square, 8a square, 8a minus 4a, so positive 4a minus 8i. And here we have a raised to power 4. Now again we will multiply both sides by a and use the above result. A raised to power 5, because we need the value of a raised to power 5. A raised to power 5 is equal to 8a cube. So again 2a square plus 4a minus 4i plus 4a square minus 8a. So our a5 is equal to 1620a square, 20a square, 32 minus 8, so plus 24a, 24a minus 32i. So our alpha is equal to 20, beta is equal to 24 and gamma is equal to minus 32. Our alpha plus beta plus gamma is equal to 44 minus 32, 12. So from here, our option A is correct. And here is our solution, and we can see that our answer is correct. Here is the next question now. This time our question says, let A be a matrix of order 3 cross 3, determinant of A is equal to 5, And here we have an equation alpha comma beta comma gamma belongs to natural numbers. Then alpha plus beta plus gamma is equal to. So here in this question, first we will evaluate this equation to find alpha, beta, gamma. Then we will find alpha plus beta plus gamma. This will be 2 will get outside the determinant, 2 cube and adjoint of 3a, adjoint of 2a will be, first adjoint will get cancelled and it will be 3a adjoint of 2a, 3a adjoint of 2a whole square. So it will be 2 cube 3 raised to power 6 and determinant of a square, so 5 square, and determinant of 2a raised to power 4. So 2 cube 3 raised to power 6, 5 raised to power 2 into 2 raised to power 12. 2 raised to power 12 into 5 raised to power 4. So we will get 2 raised to power 15 into 3 raised to power 6 into 5 raised to power 6. So on comparing, we will get alpha is equal to 15, beta is equal to 6 and gamma is also equal to 6. So from here, alpha plus beta plus gamma is equal to 15 plus 12, 27. From here, our option C is correct. And here is our solution, and we can see that our answer is correct. Here is our next question now. This time our question says, let I be the identity matrix of order 3 cross 3 for the matrix A is equal to this matrix, and mod of A, determinant of A is equal to -1. Let B be the inverse of the matrix, this matrix. Then the value of this determinant is equal to. So here in this question, first we will find the value of lambda. Then we will manipulate this given equation. Then we can find the value of determinant. So our determinant of A is equal to 16 lambda and A 34 into 2 minus 68 and 39 3 plus 117 is equal to -1. So from here we will get 2 4 minus 4 and minus 35. So this it will be minus 117 and 8 minus 42. So this will be plus 68. From here 16 lambda is equal to 48. So from here our lambda is equal to 3. our lambda is equal to 3 and B is inverse of this matrix. So we can write as B inverse is equal to adjoint of A adjoint A square. Now this term inside the adjoint, let's say this is C. So A into C is equal to A square adjoint A square, which is equal to determinant of A whole square into identity matrix. And determinant of A whole square is 1, minus 1 whole square will be 1. So our C is equal to A inverse. From here, B inverse is equal to adjoint of A inverse. We can write it as B inverse is equal to adjoint of A whole inverse. From here, we will get B is equal to adjoint of A. And let's say D is equal to lambda B plus 1. Lambda is equal to 3, so this is equal to 3B plus 1. We have our D. So A into B is equal to 3 times A into adjoint A, so this will be determinant of A into identity matrix plus identity matrix minus 3, so this will be 3 times determinant of A into identity matrix plus A, plus A. This is equal to A minus 3I. So determinant of AD is equal to determinant of 3 minus 3 is 0. 2, 3, 4, 5 minus 3, 2, 6, 7 minus 1, 2 minus 3 minus 1. 2 minus 3 minus 1. So this determinant is equal to 2 times 4 and 46 into 2. Negative, negative, positive. So this will be 292 minus 92 minus 14 plus, sorry, yes, ma'am. 4, 14, 18. Please better me. Yes, yes. 18 into minus 3. 18 into 3 with a minus. So this will be 4 to 54 minus 54. And this is equal to 38. Now we can write determinant of AD as determinant of A into determinant of D. So determinant of D is equal to 38 upon determinant of A, which is minus 1. So minus 38. From here our answer is equal to minus 38. And here is our solution. We can see that our answer is correct. Here is our next question now. This time our question says, let A is equal to this matrix if for some theta between 0 to pi, A square is equal to A transpose Then the sum of diagonal elements of the matrix. This matrix is equal to. So first, here in this question, we will check if A is orthogonal matrix. Orthogonal matrix. To check it, our A into A transpose should be equal to identity matrix. A is cos theta, 0 minus sin theta, 0 1 0 sin theta, 0 cos theta. Into this transpose of this, cos theta 0 sin theta 0 1 0 minus sin theta 0 cos theta. So this is equal to 1 0 0 0 1 0 and 0 0 1, which is equal to identity matrix. So our A is orthogonal matrix, and so from here A transpose is equal to, using this equation, A transpose is equal to I. We can say A transpose is equal to A inverse. Now our A transpose is equal to A square as given in the question. So we will get A square is equal to A inverse. This will be A cube is equal to I, identity matrix. Sorry. Now let's expand this expression. A plus I cube plus A minus I cube minus 6A. Now sum of these first two terms will be 2 times A cube, 3C1 and 3C2. So 3C2, 3A plus 3A minus 6A. 6A and 6A will get cancelled. These two will get cancelled. This is equal to 2A cube, and this is equal to 2I, which is equal to 2 0 0 0 2 0 0 0 and 2. So we have value of this expression. Then our required sum is equal to 2 plus 2 plus 2 is equal to 6. From here our answer is equal to 6, and here is our solution. We can see that our answer is correct. Here is our next question now. This time our question says, let the matrix A is equal to this. Satisfy this equation for n greater than equal to 3, then the sum of all elements of A 50. Now here we have this equation. So first in this equation we will put n is equal to 50. A 50 is equal to A 48 plus A square minus I. Now again this equation we will put A48 and substitute it in place of A48. This is equal to A46 plus 2 times A square minus I. And again we will substitute A46. We will get A44 plus 3 times A square minus I. So this is equal to A square, so on. This is equal to A square plus 24A square minus I. So this is equal to 25A square minus 24I. 25A square minus 24I. Now let's find A square. A square is equal to 1 1 0 0 0 1 0 1 0 1 1 0 0 0 1 0 1 0. This is equal to 1 0 0 1 1 0 1 0 1. So from here this is equal to 125 25 1 1 and 0 0 0 0. So from here our required sum is equal to 21 plus 1 plus 1 plus 25 plus 25. This is equal to 53. So our answer is equal to option A. And here is our solution, and we can see that our answer is correct. Here is our next question. This time our question says, let A be a 3 cross 3 matrix such that we have this equation, then S is equal to this set, then we have to find the value of this expression. So first in this question we will find determinant of A from this above equation, and then we will find elements in the set S, then we can easily find the value of this sum. So first let's open it. It will be adjoint A raised to square is equal to 81. Adjoint A 4 is equal to, we can write 81 as 3 raised to power 4. 4 will get cancelled. So determinant of A square is equal to 3. We will get determinant of A is equal to root 3. We have determinant of A. Now let's find the number of elements in this, not number of elements. Left hand side will be A square. A determinant of A raised to power 4 into n minus 1 square upon 2. So this will be 2n minus 1 square. 2n minus 1 square. And this is equal to determinant of A 3n square minus 5n minus 4. Now we will compare both the equations. 2n square minus 4n plus 2 is equal to 3n square minus 5n plus 4. So we will get n square minus n plus 2 is equal to 0. So our n is equal to 2 comma minus 1. Please wait a minute. This is minus 4. So this will be, sorry, please wait a minute. This will be minus 6. So our n is equal to 3 comma minus 2. So from here this will be sigma n belongs to S, determinant of a n square plus n. This will be determinant of a raised to power 9 plus 3, 12 plus determinant of a 4 minus 2. We will get root 3 raised to power 12, so 3 raised to power 6 plus 3. This is equal to 3 plus 7, 29, and this is equal to 7, 32. So our answer is option E. And here is our solution, and we can see that our answer is correct. Here is our next question now. This time our question says the number of singular matrices of order 2 whose elements are from the set. This set is. So this is a mixed question of PNC and matrices. Let's say determinant of A, B, C, D. This is equal to A, D minus BC, and this is equal to 0. So from here we will get A, D is equal to BC. So our case 1 will be all numbers are same. All numbers are same. In that case our determinant will always be equal to 0. So total ways is equal to select one number from these 4 numbers. Case 2, exactly 2 numbers are same. Then we will get total ways is equal to we will select 2 numbers from these 4 numbers, and let's say we have selected 2 comma 3. Then our determinant will be 2 2 in the first row and 3 3 in the second row, and we can say 3 3 in the first row and 2 2 in the second row. So into 2, and same for the columns, into 2. This is equal to 6 into 4, and this is equal to 24. Now case 3, exactly 3 numbers are same. So here in this case total ways is equal to, let's suppose if 3 numbers are same, we have numbers A, B, and A square should be equal to AB, and there is no such numbers in which we have A square is equal to AB. So total ways in this case is 0. And last case 4, exactly case 4 is all numbers are used. All numbers are used. So in that case, we have only one option. 2 into 9 is equal to 3 into 6. So for this case, let's say one example determinant is 2, 9, 3, 6. We can change order of 2, 9 and 3, 6. So, and it can also be on the other diagonals. This will be here total ways is equal to 4 in this case, and in the other case where 2 and 9 will be written in the place of 3 and 6, so into 2, this is equal to 8. So our total ways is equal to 4 plus 24 plus 0 plus 8. This is equal to 32. So from here our answer is 32. Sorry, not 32. 36. Sorry. 36. And here is our solution, and we can see that our answer is correct. Here is our next question now. This time our question says let A is equal to this matrix, and we have this determinant m comma n belongs to natural numbers, then m plus n is equal. So here determinant of, first let's find determinant of A. Determinant of A is equal to 2, 4, 6, 2 plus P, 6 plus 2P, 12 plus 3, A2 plus P plus Q, 8 plus 3P plus 2Q, 20 plus 6P plus 3Q. 8 plus 3P plus 2Q, 2 plus P plus 3, 12 plus 3P, 6 plus. So first in column 3, we will subtract column 2 and column 1 into 2 by 2. So we will get this is equal to 2, 4, 6, 2 plus P, 6 plus 2P, 12 plus 3P, 0, 2 plus P, and 8 plus 3P. Now in column 2, we will subtract it by column 1 into 1 plus P by 2. So this is equal to, this is determinant. It's equal to 2, 4, 6. 2, 4, 6, 0, 2, 6, 0, 2 plus P, 8 plus 3P. So from here determinant of A is equal to 2 into 16 minus 12. 2 into 4, 8. our determinant of A is equal to 8. 16 minus 12. Now we can find this expression. We can write it as adjoint of 3a square 3a raised to power 4. So this is equal to 3 raised to power 12 and 8 is 2 cube. 2 cube into 4. So 2 raised to power 12. From here n is equal to 12 is equal to n. Our m plus n is equal to 24. From here our option B is correct. And here is our solution and we can see that our answer is correct. Here is our next question now. This time our question says let alpha be a solution of this equation, and for some a and b in R we have this equation. If again we have an equation between m and n, then m plus n is equal to. So first we need to find a and b from this, and using the values of alpha and a and b we can find m and n. So let's solve this first. Let's solve this. Now here we can clearly see that alpha is equal to omega and omega square. It's a standard result. Now let's solve this equation. We will get 4 minus a minus 2b into 16, 64 minus a minus 14b into 52 plus 2a minus 8b is equal to 0, 0, 0. From here we will get a plus 2b is equal to 4. We will take only first two equations, and a plus 14b is equal to 64. From here we will get a is equal to 4 minus 2b. Substitute in this equation. We will get 12b is equal to 60. b is equal to 5 and a is equal to minus 6. So from above we will get from this equation, we will take alpha as omega. We can also take omega square, but we will take omega. 4 upon omega raised to power 4 plus m upon omega raised to power minus 6 plus n upon omega raised to power 5 is equal to 3. This will be 4 upon omega, so 4 omega square m into omega 6, so only n, plus this will be omega n upon omega square, so and omega is equal to 3. So this will be 4 into minus 1 by 2 minus root 3 by 2 iota plus m plus n into minus 1 by 2 plus root 3 by 2 iota is equal to 3. So from here we will get minus 2 plus m minus n by 2 and plus iota into minus 2 root 3 3 by 2 plus n root 3 by 2 is equal to 3 minus 2 plus m minus n by 2 is equal to 3 minus 4 root 3 by 2 plus n root 3 by 2 is equal to 3 is equal to 0. Sorry. Imaginary part is equal to imaginary part. From here n is equal to 4 and n is equal to 4, we will put it here. We will get minus 2 plus n minus 2 is equal to 3. So m is equal to 7. From here our n plus n is equal to 11. So our answer is option B, and here is our solution, and we can see that our answer is correct. So hope you found this video helpful. Thank you for watching.